I'm Dave Maths. I have another fascinating mathematical solution here. If x equals pq over p plus q, find x square over x minus p and x minus q. We first apply the reciprocal law for x, which gives us a result of 1 over x. Then, p plus q becomes the denominator and pq becomes the numerator. Numerator and denominator interchange in a reciprocal. In the field of mathematics, factors affecting the left side also impact the right side. In the event that 1 over x changes, p plus q over pq also changes. Then we can split, basic LCM rule for multiplication of two numbers at the denominator. One over x equals p over pq. Q over pq. The p and q at the numerator cancels out with the p and q at the denominator. We're left with 1 over x equals 1 over q plus 1 over p. Next we evaluate x square over x minus p and x minus q. We can split x square over x minus p and x minus q for easier solution. This will be x over x minus p and x over x minus q. Now we can solve step by step. Identifying the equations as equation 1 and equation 2 is the first step. For equation 1, we have x over x minus p. We will divide the numerator and denominator of the equation by x. Then we have x over x. We have another x over x minus p over x. X over x is 1. While p over x remains the same. Now we also evaluate equation 2. X over x minus q. We also divide all sides by x. Then we have x over x. We have another x over x minus q over x. X over x is 1. While q over x remains the same. After that, we go back to the original equation and replace the value of our 2 solution there. As a result of taking the reciprocal of x, this is our primary solution. We're using this equation to get the value of p over x. So what we will do is to multiply all by p to make it easier to solve. We repeat the same process for equation 2. We're also using this formula to get the value of q over x. To get the value of q over x, we multiply all by q. One over x times p. 1 over q times p. And lastly 1 over p times p. One over x times p becomes p over x. 1 over q times p becomes p over q. And lastly 1 over p times p becomes p over p. We do the same for the second equation. 1 over x times q. One over q times q. 1 over p times q. One over x times q is q over x. 1 over q times q is q over q. 1 over p times q is q over p. Finally, we can write q over x equals 1 plus q over p. We can also write p over x as p over q plus 1 since p over p is 1. Next we substitute the value of p over x and q over x into the equation above. So we have 1 over 1 minus p over x. We then substitute the value of p over x into this expression. Don't forget that our p over x is already p over q plus 1. We repeat the same steps for the equation 2. Note that q over x is the same as 1 plus q over p. To solve this we will use the minus to expand the bracket, so we have minus p over q and minus 1. From here 1 minus 1 is 0, so we're left with minus p over q. In equation 2 as well, we will use the minus sign to expand the bracket. Evaluating this gives 1 minus 1, which is 0, then we're left with 1 over minus q over p. We will divide 1 by minus p over q. Then the division sign changes to multiplication, which then makes the fraction interchange. We repeat the same process for equation 2. Finally, we're left with minus p over q. And for equation 1 we have minus q over p. Finally, we have minus q over p times minus p over q. Q can cancel q while p can also cancel p. Finally, we're left with plus 1 since minus 1 times minus 1 is positive 1. Thanks for watching. You can follow me for more content like this. Please drop a comment.